We'll get started on this as folks are trickling in. Hi, everyone, and welcome to the COTE Roundtable on reducing embodied carbon. This session is hosted by AIA California's COTE committee. So a little bit of overview for today. So we created the COTE roundtables to help with outreach to the local level, to keep the local chapters informed, and also to foster a knowledge sharing atmosphere and environment. So for today's session on embodied carbon, we'll have a quick little intro and update on what the California chapter is up to. Then that will be followed by panel discussions, panel presentations by three experts on our panel. And we'll close out with a Q&A session at the end. So just some housekeeping items. Please turn off your video and mute yourself during this presentation. I'm sure questions or thoughts are going to come up during our panelist presentations. If so, please put those in the chat box. There should be a chat button located on the black menu bar, either on the top or bottom of your computer screen. And you can always raise your hand by clicking the little raise hand icon. Heidi and I will be co-moderating this session together. So we'll be keeping an eye on the chat box and keeping track of all questions that come up. So because this roundtable qualified for an AIA HSW credit, for those attending live, we are obligated to provide you with an overview of what we'll be learning. So these are the learning objectives on the screen. Please note that AIA California staff will submit you for the AIA CA credit within 2 weeks of today's session.
Thanks, Avade. So before we launch into the great panel that we have assembled here today, we first just wanted to give a really big picture overview of what embodied carbon is and why it's important, and important focus of our work. So next slide. So far as an industry, we've really only talked about building operational energy and operational carbon, called in-use carbon emissions. And what embodied carbon does is really broaden that discussion to include all of the materials that go into our buildings as well. So rather than just focused on the building's energy consumption and whether they're connected to a green or clean grid, it really expands the conversation to other aspects of the global CO2 emission impacts, which is materials. And as you see in the image here, around the globe, we're going to be building an equivalent of a New York City every month, which is projected to occur for the next 40 years. So we have a really important opportunity to focus on here. Okay, go ahead, Abade. So to put this into perspective, this is showing a chart here of the US GHG emissions as a whole. So carbon dioxide comprises 85% of the GHGs, and the remaining 15% is comprised of HFCs, PFCs, SF6, methane, and nitrous oxide. Lots of acronyms here today, so please post any questions in the chat. So then this slide is an overlay with the green, and that shows the operational emissions, and those are the ones that we're more used to, right? The residential buildings, the commercial buildings are those two big chunks. Then there's a few other miscellaneous items for, transmission losses when supplying electricity to consumers, and some fugitive emissions. And then this slide here, we've layered on in blue the embodied carbon, and that gets to, close to most of everything else for our GHG emissions, because the embodied carbon, that includes the transportation of the materials as they're moving around through the supply chain, also includes the energy that goes into processing any chemicals or petrochemicals in our materials. And then also too, just want to point out the impact of cement is significant. Cement alone is responsible for 2.3% of US GHG emissions. Okay, next slide. So here's a snapshot of what's included in embodied carbon. So embodied carbon counts all of the energy that goes into the materials that create our buildings from the very beginning, with extraction to transportation and manufacturing and processing, and then also to all the energy that's needed during construction, but also through ongoing operations and maintenance. And then it further expands into waste and disposal and recycling and the end of life of these projects. So the energy associated across this entire spectrum is expressed in carbon dioxide equivalents, or CO2e, and that's collectively considered the embodied carbon footprint. Okay, next slide. So embodied carbon assessment, it's really a subset of most life cycle analysis, or LCA studies, as it really only focuses on the specific GHG environmental impact. But it's really important to note that the whole building life cycle analysis does more than just the embodied carbon impact. It looks at numerous other environmental impacts like eutrophication, acidification, smog potential, etc. And then another really important layer too is the human impact aspects, which are some are listed along the bottom two rows there. But the human health impacts across the entire supply chain. You know, when we specify healthy and natural materials, it benefits not only the building occupants, but everyone along that supply chain. So the fence line communities where fracking is happening, the manufacturing and construction workers who are working with these materials day in and day out, and then also too, at the end of life, anyone handling that material. So why are we talking about embodied carbon? So here you can see some research that was done in 1980. Operational carbon dioxide was the main focus because it was really the greatest percentage of the overall building carbon footprint compared to embodied carbon. Okay, next slide. So now that we have been adopting some great energy efficiency measures, we have much more stringent building code requirements now. So we're really getting to a point where we're drastically reducing our in-use carbon emissions. And then next, thanks. So now the focus really needs to be on embodied carbon, because as you can see across the same trajectory, there just really hasn't been a focus and a dent in this. So we really need to transform the market quickly and really to help us all meet our collective carbon reduction goals. So this is a really powerful statistic to kind of leave you with and really underscore that the time to act on this is now, and really important to start educating ourselves and our clients on these topics. So with that, I'll pass it back to Avide, who's going to talk about the policy landscape.
Thank you, Heidi. So that was a little bit on why embodied carbon is important. With AIA California COTE, we've had a particular focus on the policy landscape, as some of you may know. Currently, there's quite a bit happening in terms of embodied carbon policies underway. So this slide here is just a sampling of the many different policies underway right now. Some of these have already passed and gone into effect. Some of them are still trying to garner support, and there's still hearings for these and workshops. So a couple of the ones I'd like to highlight is first of all, that California has a Buy Clean California Act, BCCA for short, that actually sets GWP thresholds for certain product categories, including structural steel, insulation, and glazing. This Buy Clean California Act applies to all state-owned and operated buildings. So it's not the building code. It doesn't apply to all buildings. And it is missing some crucial materials like concrete. So SB 778, which is a bill that's in the Senate right now, is actually attempting to add concrete to the Buy Clean California Act to set GWP or GHG emission thresholds for concrete as well. There's also SB 596 in the works currently, sponsored, I think NRDC is also working on this bill, and that's specifically for low carbon concrete legislation. That bill really establishes CARB, the California Air Resources Board, as the state agency having to set thresholds for low carbon concrete. At the in other states, so Low Embodied Carbon Concrete Leadership Act was enacted in New York, for example. At the federal level, there's a federal Buy Clean Transparency Act that came about in 2019. And again, at the local level, again, there's Marin County's Low Carbon Concrete Concrete Act that is establishing GWP thresholds for concrete mixes specifically, and it's at the leading edge of policy. So there's a lot happening right now. A lot of different organizations working on putting these thresholds into policy so that it can be implemented. Here's a snapshot, a slide that I borrowed from the Carbon Leadership Forum, where they're tracking all of these policies and what they cover and what's needed to support these policies to get passed, which AIA California is actively engaged in. So for this reason, at AIA California, we have formed an embodied carbon working group. Heidi and I sit in that working group. And really the intent of this working group, first of all, is a collaboration, it's a partnership between AIA California and USGBC Los Angeles chapter. And the intent is twofold. One is to educate our architects on embodied carbon, really hunker down on more deep dive educational sessions on embodied carbon, what it is, how to calculate it, how to use it to your advantage as an architect. And then perhaps developing incentives for architects to run whole building LCA analysis. That's something that we're beginning to discuss. And then the second part of it is advocating for policy. While AIA California, as volunteers with AIA California, we may not all have the time or the expertise on policy. We can do certain things to support our allied organizations like the Carbon Leadership Forum and NRDC, the New Buildings Institute, to advocate for embodied carbon policies that they're working on. And also one of our goals eventually is to advocate for advancement of embodied carbon metrics in city reach codes, and also specifically in the Cal Green Building Code, because right now there's nowhere in the building code that requires embodied carbon thresholds. So this is a very new working group. We are looking for anybody who is interested in joining, any architects currently tuned into this presentation. If you're interested in being involved more at a state level and advocacy level, or putting together educational content, please reach out to myself, Heidi, or Hillary on this chat. And now introduce our roundtable speakers. So today with us, we have John, who will be speaking to adaptive reuse and the embodied carbon angle on that. We have Baha with us, who will be speaking to the LCA lifecycle assessment workflow process. And we have Patti with us, who will be speaking more from a structural engineer's point of view and offering case studies on the reductions that can be achieved and how to do it. With that said, I will pass it over to John. John, if you want to share your screen.
Sure, thanks. 1 second. Okay, can you see my screen?
Yep.
Great. My name is John Delaney. I'm an architect with Koenig Eisenberg in Santa Monica. And I'm just going to kind of touch on the issues that relate to embodied carbon and adaptive reuse, kind of at a more general level, getting into some statistics, and then sort of diving into a few case studies that we've done that kind of illustrate, what we're talking about in terms of getting benefit out of those projects. So the building industry in general, so actually trying to find data on this is a little bit difficult. So we're sort of just working with what's available right now. So according to the EPA, approximately 1 billion square feet of buildings are demolished and replaced with new construction annually. It's almost such a big number that it's difficult to think about outside of your project. It's on a national scale, it's just a lot of square footage. And it's projected that by Brookings Institute that over 82 billion square feet of existing space will be demolished and replaced between 2005 when the initial report was issued and 2030. So we're kind of in the middle of that right now. That includes new construction and renovation. So quite, I think that represents in the study maybe 25% of the overall building stock. So it's actually quite a lot of square footage, and it's possible that by 2030, most of the buildings that will be available for occupation will have been built in the last 30 to 50 years. So not a lot of old buildings will be left by 2030. And 600 million tons of demolition waste was produced in 2018, just as an overall figure of yearly waste, and 90% of that comes from demolition, only 10% from new construction, from waste from new construction, and almost 25% of that gets sent to landfills. So we're making good progress on getting that diverted to secondary uses, but still quite a lot of material is going to landfills. So current research tends to indicate that in almost all cases, adaptive reuse is more environmentally beneficial than new construction. The amount of benefit that you get is dependent on a lot of things. According to the research, which was done by the National Trust for Historic Preservation, the benefit can range anywhere from between 4% and 46%. So once you get more towards that 46% benefit, that's quite a substantial benefit over new construction. It tends to depend on use. So if you look at the next chart, this is sort of explaining the average payback period for high performance new construction versus baseline performance adaptive reuse. So even if you don't engage in high performance adaptive reuse, you still get quite a big benefit. So for example, in Portland, if you were to do an urban village mixed use as adaptive reuse, it would probably be an 80-year payback to do that same building in high performance new construction, according to the study. This can go all the way down to maybe 10 years in Chicago if you're doing an elementary school. The only case where you would not get much benefit is according to the study, is in a warehouse to residential conversion. So basically taking a warehouse and converting it to residential lofts, because you've got to do quite a lot of new material in terms of adding partitions and envelope improvements to make that work. So that's the only use scenario where adaptive reuse is most likely not beneficial. So if you think of embodied carbon, so how much material is in a building? In an average concrete building, the structure is between roughly 50 and 75%. And then everything else is the other percentage. It depends on the efficiency of the structure, whether it's a flat slab or a post and beam or some other type, or a waffle slab or some other type of system, but it varies between roughly half and 3/4. So if you think of it that way, just preserving the existing structure gives you a lot of benefit. So once you kind of have that in mind as a basic strategy, you can start to think about other basic strategies that will get you to very low embodied carbon. So with structure, retain a majority of the existing structure and add minimal new structure where it benefit program or performance. It's very difficult to do one of these projects without some intervention, but as long as you do it in a thoughtful way and preserve as much of the existing structure as possible, you can get a pretty good result. And then with everything else, a majority of the embodied carbon goes into envelope upgrades. Depends on the age of the building as well. So the older the building, generally the more envelope upgrades you have to do. Equipment and appliances, they tend to have a very short lifespan. So you're probably going to have to replace them just to meet code if the building's over 30 years old. But ultimately, the type of equipment and appliance you replace generally depends on sort of a life cycle and cost benefit analysis, because adding high performance equipment doesn't necessarily give you a whole ton of benefit in terms of cost. So repurposing doors and other finishes, windows, furniture, and other assembled components, recycling other components that are not easily reused, using new low carbon finishes only where necessary. And then you'll have to do accessibility upgrades and other code related issues. That's just part of doing these projects. And then utilizing outdoor space and landscaping. And in California, that's very important. And you get a lot of benefit from doing that. And not a lot of, in fact, you're actually adding, you're sequestering carbon in the plant material that you add. So that's actually a big benefit. So the real big sort of overarching principle of these projects is to shape your vision and values early on. So you have to decide basically on day one whether you're demolishing or saving any existing assets that you have. Sometimes the clients come to us with that already determined, and sometimes they ask for our input. It sort of depends on the project. But I guess the important thing is that on day one, the decisions that you make have a huge impact on embodied carbon. So you have to just be aware of that and get as many team members involved as early on as possible to help shape these decisions. So part of the decision making is evaluating the site potential. So there could be a historic preservation component, and with historic buildings, you often get a tax credit. So in some ways, it helps to make that work out financially. There's community partnerships and social missions that you could help to develop that often make these projects, it gives them an added benefit to the community. There's the urban context. So in some urban infill lots, it's quite difficult to demolish and build new. So a lot of times it's just worth it for the city and for the urban area to just renovate what's there as long as it's in good shape. And then you sort of have to evaluate the potential of the building, making sure it's a rough program fit and that it's roughly compatible with the program that you're trying to put in, and that the building's in good structural condition so you don't have to do too many retrofits to get it to work from a structural point of view. So I'm just going to run through a few projects that kind of illustrate these points. This project is called Museum Lab. It's a building that's in Pittsburgh. This is a good example of sort of reusing what's already there. The scrim wall was formerly flooring panels, perforated metal that were sandblasted to kind of give it this really kind of industrial look. And it also goes to show that you can really kind of do very minimal things to the existing building to get a lot of impact, which is going on with the columns and the archways. This building was an existing building that was designed in 1890. It was one of the first Carnegie libraries in the United States. It's been owned by the city of Pittsburgh since the 70s, which struggled to maintain the building. And it suffered a lightning strike in 2006 that made some of the building unusable. So for about 15 years, the building was empty. It was at some point partially occupied by a theater group, but most of it sat empty. And the Children's Museum, which was a nonprofit educational organization, is moving in. So utilizing those existing cultural assets. This building is also part of the Pittsburgh 2030 district, which is one of the largest in the nation. So it has a commitment to net zero energy construction and overall sustainability goals. So that's a benefit when you're trying to do these projects, is having community support. Also, the client was very supportive of doing the most sustainable building possible. So you can kind of see the state of the existing building, that the city did a lot of very, very bad patchwork retrofits in the 70s and 80s just to kind of cover up some of those old details. So the idea of the building was really just to remove all of that and not do anything new. So, and just to kind of stabilize what's there. And by doing that, by sort of minimizing your intervention and just taking things out rather than adding things, you really reduce the embodied carbon impact. And this kind of just shows a section of what's existing in black, and then what's been just renovated, which is in green on the plans, and what's in blue, which is added new. So there's only just one small area of floor that was added, that was new. And then a new roof and skylight above in the gathering space that kind of gives the space a new character. So this is an example of doing envelope upgrades that are kind of outside of the box. The exterior wall of this building is a 4-wide brick wall with stone veneer, which is kind of, it's not a construction type that you're going to run into much. these days. So in order to improve the thermal performance, one of the things that the project team came up with was to use sort of a thermal plaster, which is made from cork, clay, and earth. And what that allowed us to do, even with 1 inch of material, is basically almost double the R value of the wall, because you're not getting much R value from the brick and stone, almost an R4. And from the thermal plaster, you get an R3. So you're almost doubling the R value of the wall. So that helps us to really improve the thermal performance with very minimal added material. And you can kind of see the result of the interventions. It's working to preserve as much of the existing structure as possible, which as sort of this Richardsonian Carnegie Library is really beautiful. And we were kind of amazed peeling back the layers, what you could get out of it. It's pretty amazing. And doing art installations, the image in the top left, there's an art installation by Friedland Buck, which is a really easy way to add character to the space without doing much architecturally. Just kind of some more images of what that is. So the image at the bottom right is new floor area that was added, still integrating with the existing building. What was interesting about this building is that energy use wise, we actually reduced energy use versus what it was pre-renovation. So you kind of see from this chart here what it was before, when it was just kind of very leaky. And once we improved the envelope by adding insulation in the roof and patching up leaks and redoing the windows and adding thermal plaster in the occupied spaces, you actually are using less energy once it's occupied post-construction than you were previous. So we're not only reducing embodied carbon, but also operational carbon as well. So you can kind of see how that's working. This project is was formerly a YMCA. It's the 28th Street apartments. This is a Paul Revere Williams building that was designed from the 20s. It fell into disrepair. And so the program of this building was to renovate the communal areas, which feature kind of like support spaces and a gymnasium, and also to do to renovate the above spaces, which are dormitories, which you find a lot in these old YMCAs, and then add some new apartments as an addition. So you can kind of see the diagram of what's new and what's existing. And this building was pretty suitable for this use because of the existing dormitories, the floor plate laid out well for apartments. So this is the kind of evaluation that you do up front, and not to mention the cultural value of a building that was designed by a fairly well-known architect, very important as an African-American and to the LA architectural community in general. So yeah, just trying to honor that building, and by doing an addition that is respectful of that. So you can kind of get an image of the addition, and also making really good use of the outdoor space. I'll just keep touching on that on LA projects. Really adds a big benefit without doing much architecturally. Some additional photographs, and then working with the existing structure, you have to find places to put things like HVAC units and solar panels. So you have to kind of really put your thinking cap on and do some problem solving, but it ends up providing an architectural benefit to the building as well. Then the last one we'll look at is Geffen Academy at UCLA. This building is not that old. I think it was done in the early 90s. But what it was is the building's purpose was to temporarily house displaced programs on campus. So it never really had its own identity. It was just kind of filled with offices and fitness spaces that were too big for the existing gymnasiums and other things. So there was a new K through 12 school that was looking for a permanent home. So they partnered with the university and took over this building. So just as a strategy, the idea was to move the front door to the south, and then just utilize landscaping and the existing parking, create a really, without doing much to the building itself, create a really nice welcome area. Whoops. Not sure what's going on there. So in terms of architecture, really the only major intervention was to add a monumental stair and take advantage of the existing skylights, and really just allow that light to filter through, and then make that kind of a hub, and really just take advantage of what's there. You can kind of see some of the landscape strategies that make the outdoor space really active, and with really just adding sort of this cable feature as kind of a sculptural element, and some overhead canopies for shade, really minimal interventions. And sort of bringing that idea of indoor-outdoor to some of the interior spaces. And that's about it.
Thank you, John. Baha?
Sounds good. Thank you, John and Avide. Hi, everyone. My name is Baha Sadreddin. I'm an associate principal and high performance design specialist at ZGF Architects, based in Portland, Oregon. Today, I'll be sharing a presentation on embodied carbon, on basically LEED workflow, whole building LCA workflow. Since other presenters have done a good job of covering the basics of embodied carbon, and John has done the adaptive reuse, and Patti will be talking about structure. So basically, one of the reasons I selected LEED for this, or LEED as a topic for this presentation, was that LEED has been a big driver in the work that we do in terms of embodied carbon, especially with the changes in LEED v 4.1. So in LEED v4, there was one threshold under the building life cycle assessment credit that you would get 3 points with a 10% reduction. In V4.1, the changes allow you to get 1 point guaranteed by performing a whole building LCA. So you could really get your feet into doing whole building LCAs and even not showing any reductions or increases, just doing your proposed design, you would get 1 point guaranteed. You would receive 2 points with a 5% reduction, which could be fairly easy to achieve with some optimization. 3 points with 10% reduction, which is shared with LEED v4, and 4 points with 20% reduction, and also building reuse or salvage materials. So this has really gotten many clients and designers interested into doing more LCAs, which has been a great change. In terms of scope of what to include in LEED, the minimum that you could include is the building enclosure and the structure. Interior is optional. I really recommend that for the sake of LEED documentation, only include things that are required and you are optimizing, because it might make the documentation process a little easier. But for the sake of carbon, look at everything and try to optimize as many materials as you can. Electrical, mechanical, plumbing, and elevators are not required to be included. Excavation and site development, not required. Parking structures, you need to include them. So if you have parking under your building, you need to include it, but parking lots, you do not include. And then from a tools perspective, the workflow that we use is Revit and Tally. You could also use other tools, like your tool needs to be cradle to grave. So tools like Tally, Athena, one-click LCA would provide cradle to grave studies. EC3 is a cradle to gate tool right now, even though Tally and EC3 are merging now. The example that I'll be using to go over the workflow is the California Air Resources Board project, Net Zero Office Building. Basically, for an effective LCA workflow, you just need to start really early, and it's a process that needs to continue throughout design and construction. And it's also a very collaborative process, so it's not something that the architects really could do by themselves. It needs many folks involved. The structural engineers are really important because the structure has a really large impact, and contractors, suppliers, and so on. So start early, but then also know that if you have projects that are ongoing and you haven't really thought about embodied carbon reduction, there are many materials, concrete being an example, that you could really have large impact up until the point of construction, where you might have opportunities for changing a mix design without necessarily changing your structural design. And this is one, there are low-hanging fruits that you could have large reductions up until later into the design process. So try to start early, but if you haven't, still look into it. And then the process in general with whole building LCAs is not very perfect right now. It's emerging. As you get deeper into the data, you see gaps, you see how different resources might show different numbers, or how your LCA accounting might be a little different, but we just need to do more of it to make it better over time. Early in the design process, from a modeling perspective, it's very helpful to look at kind of design options and bay models. So when you still don't have a whole building, model, you just want to kind of create bits and pieces from the building and do studies where you could select some materials, and it's also easier to have a smaller portion to study. Later in the design, it becomes difficult. Let's say you have a really large building with thousands and thousands of elements in Revit. Design options become more difficult. So now you kind of look into detaching your model and then making some changes. Work set management becomes really important. In minimal, you have your structural model, and then you have your enclosure model. Hopefully the structural model is the model that you get from the structural engineers, because that's the most accurate, and then the enclosure from the architects. For lead purposes, again, you create a copy of your structural model to create a baseline, and you create a copy to create a proposed model. You do the same with your enclosure model, a baseline and proposed model, and then you link the baseline models together and the proposed models together to create your lead baseline and lead proposed models. Again, I mentioned that interiors is optional. I recommend looking into it, but you do not necessarily need to include it in your documentation. Work set management, I would recommend at least a minimum of having an exterior, interior, and structure work set in your architectural model, just to be able to differentiate these. And then this is also how Tally is able to see different components in a building. So you could filter by families, and you could also filter by work sets. So let's say if you do not want to include your interior, you just uncheck the box. Creating the baseline and propose, there's usually a lot of questions in terms of how you create your baseline model, and the lead language might be a little vague. I really recommend to make your baseline by creating a copy of your proposed. So things that I do not recommend is making your baseline worse to pretend that the proposed model is better. So adding too much insulation to the baseline to make the proposed look better, or adding more mass to make the proposed look better. So I try to be fairly conservative between the baseline and proposed, but only really change the materials that you have focused on optimizing, let's say concrete, steel, insulation, and so on. So you create one of your models. I recommend starting with the proposed model. There are some naming convention recommendations that I'll go through next. And then you make some changes, fix the model, and then you input all the materials that are shared between your baseline and proposed. This would save you quite a bit of time, because now maybe 90% of your material is assigned in your proposed, and you just copy it and create your baseline and just change the ones that are changing between the two. In terms of material optimization and documentation, kind of like run an early study to understand what the high impact materials are. The yellow here is concrete, which in any concrete building, you might see a chart like this, similar to what John mentioned. This building has 69% of all the impact is coming from concrete. The rest are, metals, insulation, masonry, glazing, and so on. Typically, we focus our LCA documentation for lead purposes. We really focus on high impact materials. So any steel and metals, insulation, wood could be high impact depending on the sourcing. And the biogenic carbon accounting, and then concrete, always a giant in the room. For material naming conventions, Tally recognizes material names, materials with the same name. So it's kind of an opportunity where you could change your naming convention and you assign one material and it'll apply to all the ones with the same criteria. Concrete, as an example, the naming convention that I personally use, I usually, in our typical models, we might just say concrete. But I usually add a dash, application dash strength. And this is something that I also share with our structural engineers because it covers the application. And it also covers the strength, which makes defining your baseline and proposed models very easy. But at the same time, if you have the same strength material between your, let's say, slab on grade and columns, but let's say your reinforcement's different, it still allows you to differentiate between the two. So this kind of, in my mind, covers everything with concrete. In Tally, we usually use the cast-in-place concrete mix, custom mix, so we could type the custom ingredients versus using the defaults, which are larger ranges. Studs could be one. In Revit, we usually model them as just kind of like a solid cavity. I recommend, having the type of stud that you're using, let's say metal or wood, the spacing, and then whether it has insulation in between the cavity and what type of insulation. And then this kind of matches what happens in Tally in terms of, type of stud, spacing, and so on, and insulation. Mullions, another example of things that we need to look into carefully, because in Revit, they're usually modeled as solids, but if you end up accounting for them as solids in Tally, your aluminum, let's say, might be like 10 times more might be showing 10 times more impact than it should really show. So type of mullion and also the profile of it is important to take into account. These were just a few examples of materials. Think about materials that might be modeled differently from your physical representation, from their actual representation in the building to your model. There are also tools. We've created a concrete LCA tool, the ZGF concrete LCA tool, to be able to predict kind of the impact of high impact materials like concrete, as an example, before doing our whole building LCA models. There are also other tools that you could look into, or you could even create your own kind of like simple Excel spreadsheet for, let's say, wood, steel, or insulation, and kind of predict what you would get without having to run a whole building LCA as you are doing design optimizations. The example that I showed, the California Air Resources building, we were able, for instance, for concrete optimization, we were able to reduce the amount of cement by roughly 4 million pounds, which led to a 15% reduction in global warming potential of concrete and a 10% reduction in the whole building global warming potential, getting us 3 points under LEED V4.1. And if you have a building that's pursuing LEED V4, you could only upgrade, on a credit by credit basis. So you could only upgrade this credit to V4.1. We always talk about embodied carbon, but as we do whole building LCAs for LEED, there are also 5 other environmental impact categories that you need to look into. So ozone depletion, acidification, eutrophication, smog, and then non-renewable energy demand. None of these categories could be increased more than a certain threshold, and at least 2 more need to be reduced in line with global warming potential. So if you are pursuing a 5% reduction, 2 more categories need to also show a 5% reduction. If you're doing a 10%, 2 more need to show a 10% reduction. Something else to look into is also the global warming potential intensity, or the impact intensity. Think about EUI and how some years ago we didn't really have very good data on EUI. I really recommend looking into this data, so the amount of impact that you have per square foot of design, and hopefully over time the industry could share more data and we could really start to compare our buildings to each other, why one of our designs might have more impact versus another one having less impact per square foot. Another example, and I'm just sharing the data on this one, the DGS Clifford Allenby building, also a net zero office building. We were able to hit a 14%, almost a 15% reduction in global warming potential. And the impact intensity here is lower. So the design is just using less concrete, less carbon, embodied carbon, as you see. And then one more example is the NFDA Engineering Analytical Center. This building, the interesting part about it was that it was a steel building, but even though it was a steel building, concrete, it still had, with all the footings and slabs and everything, had such a large impact that by optimizing the concrete, we were able to reduce the overall global warming potential of the design by 11.4%. But because the other two, we couldn't really get the two more categories to show the 10% reduction, we still got 2 points under LEED v4.1 versus 3. This is it from me. Thank you, everyone.
Thank you, Baha. A lot of information. I'm sure there'll be some questions coming in. Patti?
Yeah, thank you. Let's see. Now, can you all see my screen?
Yes, we can.
Great. My name is Patti Harburg-Petrich, and I am a structural engineer and a principal in Baha-Sadreddin's LA office. And, I think John did a good job kicking this off. And I'm sure we're all familiar with this quote from Carlo Elefante, the greenest building is the one that's already built. So I'll just say that in the beginning, like we really need to be, I think, making more of an effort to reuse our existing building stock and being creative, as John described, on how we can best make the most of that. We have done some studies to look at this. How does a renovation compare to a new build? This is a confidential public assembly project. You can see that the renovation was 2 million kilograms of CO2 equivalent. The new build was 19 million. So the renovation was only about 10% of what the new building cost was. So you can see it's very significant. I'll run through this very quickly since Baha did such an amazing job going through it just now. But one of the things that we've been looking at, and just like Baha mentioned, is using LCA as a design tool. This is an airport project in California where in concept design, we evaluated a number of structural concepts and looked at the LCA impact of those different concepts. And one of the interesting things that came out of that is we found a very strong correlation between embodied carbon and structural cost. By using LCA as a tool early in the process, we were able to come up with a solution that was not only more sustainable, but also cost less. And that made it a very easy conversation with the client. It was very obvious which direction we wanted to go. To measure embodied carbon, we use a variety of tools. But essentially, and Baha just went through this, so I'll run through it quickly, but we look at the quantities of building materials, the global warming potential of those materials, and through that, we can determine the whole building global warming potential. Baha has developed a tool. It's called the LCA Toolkit. This is an open source tool that's available for free to anybody. And what it is it provides a way to integrate between different analysis and design platforms to easily get LCA output. So you can see here we're inputting info from a Rhino model and a Revit model. We use the LCA Toolkit tool, and it spits out the global warming potential. So I've got the link there. Like I said, it's free, open source. So it's another tool in addition to Tally and One-Click LCA and the others. So what I really wanted to focus on today is routes to reduction. And as Baha mentioned, one of the strategies that we've used are base studies. And you can see some of the output here. I know it's hard to read on the big screen, so we've summarized it in this next slide. But basically, by looking at different design parameters like the foundations and materials grade, by increasing the strength of the concrete in the foundations, we could potentially make the foundations smaller. Looking at different grid sizes, looking at what is the most efficient floor system. And through a combination of all these different strategies, we can drastically reduce the embodied carbon in the structure. One of the things I'd like to point out is that if you look at the baseline scheme, you can see that a concrete building has much more embodied carbon than a steel building or a timber structure. But by using the right strategies, if you look at this bottom line here, you can see that we can get to a really nice embodied carbon number, or a more favorable embodied carbon number using any material. It's just important to use the right strategies. It's easier to get there with timber, but you can achieve good embodied carbon numbers with steel and concrete as well. And so I'll go into some of those strategies now. So concrete accounts for about 8% of global CO2 emissions. And this is largely due to the intensive process of creating cement. 1 ton of cement produces 1 ton of greenhouse gas. And so in the concrete cement production process, CO2 is generated in 2 ways. The first is from the chemical reaction, which takes place within the kiln. And this produces a lot of CO2 as a byproduct. The other source is actually the energy that it takes, the energy generation it takes to power the kiln. So the embodied carbon of concrete can be reduced by decreasing the amount of cement, which is something I think that everybody on this call is already familiar with. There are these traditional reduction measures using fly ash as a cement replacement. Fly ash is a byproduct of the coal industry. It's a natural pozzolan with a low embodied carbon. But one thing to think about is, as coal burning power plants are taken offline and replaced, fly ash, the availability of fly ash will decrease, and fly ash is already difficult to procure in areas like the West Coast where we have less coal power. Another option is slag. This is a byproduct of the steel making industry. And then a third option is silica fume. This has been used for many years now. This is not as common as fly ash or steel slag. It's a byproduct of the production of silicon metals. This increases the density of concrete and is usually used in conjunction with slag and fly ash. But there are some really interesting emerging carbon reduction technologies. One of these is called Positive. Positive is a ground glass pozzolan made entirely from recycled glass. And what I think is really interesting about this is essentially what Positive does is that they take this recycled glass and grind it very, very fine. And this very finely ground glass reacts chemically the same way that cement does. Another benefit of this is that Positive does not absorb any water, meaning less water is required in each mix, which also in turn means that you need less cement in the mix. Positive says that they can reduce cement by up to 50%. And so in turn, that would reduce the GWP by about 50%. Another option is geopolymer concrete, and Geopolymer Solutions is one of the leading producers of geopolymer concrete. With geopolymer concrete, some type of cementitious replacement like fly ash is combined with an alkaline solution to produce aluminum silicate. And this can reduce GWP up to 90%. It's expensive to produce, so it's not used very often, but this is another option that's commercially available. Biomason takes their inspiration from a naturally occurring, the natural occurring process that creates coral reefs using bacteria. So first they take aggregate, inoculate it with bacteria, and then press that aggregate into a specified shape. Right now what Biomason is making is paving stones. The aggregate is then soaked in a solution that's similar to seawater, and this starts a process of calcium carbonation with the bacteria, and it creates a material that Biomason calls biocement. One of the nice things about Biomason's product is that it can be created in ambient temperatures. So, unlike the typical cement production process, it doesn't take a lot of energy to make this biocement. Right now, the Biomason is making non-structural products, but they are working towards a ready-mix concrete product that is on track to be released in 2023. And then another option is graphene. And I imagine you all have heard of graphene. Graphene is a single layer of carbon atoms. Graphene flakes are mixed into concrete to increase the strength and permeability. This reduces the embodied carbon of the mixture by reducing the amount of cement that's required. It's an inexpensive solution that is that could be used for just about everything. Graphene additives haven't yet reached the US market, but this industry is emerging. And just sort of a side note is that Rice University has recently announced they've been able to extract graphene from used tires. So I think this is a really exciting opportunity that is non-proprietary, but could have a big impact and could also help us take advantage of some of the existing waste we have. That's another thing I think that's really interesting about Positive is, you know, we've been struggling to find a way to what to do with our recycled glass. You know, a lot of it's not getting recycled. Well, if we could use that glass to instead create a cement replacement, that kind of takes care of two birds with one stone. Another strategy that structural engineers are looking at is carbon sequestration. And Carbon Cure is probably the product that most folks are familiar with. Basically, Carbon Cure incorporates CO2 into the mix, which reduces the amount of cement that's required. Carbicrete is another option here. I think that I accidentally stopped sharing. Can you all see the screen?
No, you stopped sharing.
Okay, just one moment. I hit the wrong button.
Such exciting new technologies these days. I love it.
All right, can you see the screen again?
Yes.
Okay, great. So Carbicrete is similar to Carbon Cure. Let's see. And then another option is Solida. And Solida is also similar, but instead of replacing cement, Solida creates their own. It's made of the same limestone and sand found in traditional cement, but the proportions are manipulated in order to cook them at lower temperatures. So that requires less energy and less greenhouse gas. And then Blue Planet is another option, another emerging technology. Blue Planet sequesters CO2 in aggregate rather than in cement. And next I'll talk about steel. So even though steel is relatively easy to recycle and most steel comes from recycled material, the current demands surpass the availability of recycled content. That means that we're still producing a significant amount of virgin steel. Almost all steel is created using a basic oxygen furnace. The other common way steel is produced is with an electric arc furnace. Both of these processes, there's a high carbon cost. So the primary path to carbon reduction is to use hydrogen rather than coal or natural gas for iron reduction. Instead of having CO2 as the byproduct, water is the byproduct. The other way to help reduce the carbon impact of steel production is powering furnaces with cleaner, sustainable sources of energy. And steel production currently accounts for 7 to 9% of global CO2 emissions. So one opportunity to reduce carbon production in the steel industry is carbon capture. Since the reactions in steelmaking produce a large amount of CO2, some manufacturers have started capturing this to use for other purposes. ArcelorMittal is one of these companies, and you can either store it, but even better, repurpose it for other purposes such as chemical manufacturing. And perhaps in the future, we could sequester the CO2 in concrete using Carbon Cure or Blue Planet or one of these other technologies. Another strategy, another emerging strategy is what's called hydrogen direct reduced iron. And as I mentioned briefly before, this uses hydrogen instead of natural gas. The only byproduct of the process is water. There's a Swedish project right now that's doing this. It's called Hybrit, Hybrit. And they claim that this technology could reduce carbon emissions by 95% compared to a traditional process. The other thing that's kind of exciting about this is that this process can make use of existing infrastructure. So we could take advantage of the existing basic oxygen furnaces and electric arc furnaces that already exist. And this is targeted to be commercially available by 2026. And then a third strategy is what's called molten oxide electrolysis. This was developed by Boston Metal, which came out of MIT. And so instead of using CO2 to reduce iron and create steel, Boston Metal uses electrolysis that this process creates a lot of oxygen, and the oxygen gas refines the steel. Boston Metal claims that they can produce steel that emits 0 greenhouse gas if their reactor is powered by sustainable energy sources. But there hasn't been any third-party verification of this claim yet. They're planning to have their first demonstration projects going by 2025. And then in closing, this is actually something that I heard this morning. Enlai, we were talking about a project, and he said, you know, we really need to consider the value of what exists before doing architecture. And I thought that was a perfect way to close today's conversation. And that's the end of my slides, and I'm happy to answer any questions.
Thank you, Patti. Very interesting new materials and technologies. Thanks for sharing that. And thank you, John and Baha, as well, for your engaging presentations. If anybody has questions, please feel free to speak up, directed at either a specific speaker or maybe it's an overarching question. There's a few in the chat box. I'd like to address one of the overarching comments that came in. And I'm not even sure if our panelists here are aware, because this was a very recent announcement by the California AIA. But we just announced a climate emergency. And we stated that all projects need to reach 0 carbon in 2 years. The question is, how are we, and I'm assuming we refers to architects, how are we to calculate 0 embodied carbon for a project? Is there a program that the AIA endorses? And so before I pass this question off to our panelists, because I'm sure you all have thoughts on how to calculate 0 embodied carbon, I would like to make one clarification on the climate emergency that we did declare. Our language should have probably been a little bit more specific. The 0 carbon emissions buildings declaration is regarding the operational carbon and offsetting operational energy usage. At this point, we are tracking for reductions. We'd like to encourage all members for reductions in embodied carbon, but the expectation is definitely not to have 0 embodied carbon buildings in 1 to 2 years. And maybe this is a good time for our panelists to chime in on that and when, you know, what the timeline is when we think we could potentially have 0 embodied carbon buildings. I'm not sure, but I'd love to get your takes on it too.
I could add a little bit. Yes, zero embodied carbon is just really, really hard to achieve because any component in a building has some embodied carbon associated with it. So the only way to get there, in my mind, is to have many carbon sequestering materials that not only get their own impact to zero, but make your, allow for, let's say, some steel to come into your building, but have a carbon negative impact. So basically, to be able to offset it. Right now, a big challenge I really recommend to just look into optimization for now, especially, in low-hanging fruits like concrete or steel or other opportunities for large reductions. And then hopefully over the next few years, we could take steps to get closer to zero embodied carbon.
I think one of the challenges also is, I think over half, if not 2/3 or 3/4 of all buildings constructed in California are single family residences. So a lot of times when we're thinking about projects, when you think about the mountain, it's the projects at the top of the mountain that we're talking about, which if you have the right client and if you have the budget, you can achieve some pretty lofty goals. But if we're talking about raising the entire floor of the entire base of that mountain to a zero carbon, it's like, are homeowners responsible for that? So it's a really difficult question because you're talking about a lot of construction that sometimes doesn't even come across the desk of an architect, so or an engineer. So that's probably the biggest challenge, is raising the floor rather than the ceiling.
Yeah, I heard something interesting today, that the cost of demolition is rising. And so I think that those kind of drivers, where it's more than people just wanting to do the right thing, but where there are economic drivers to reduce carbon, that's when we're going to start to see some momentum. And John, I do think that homeowners are responsible. I think we all are responsible, just as citizens of this, this planet. So if we're ever going to make meaningful change, we all need to be participating. Otherwise, it's just never going to happen.
And Mark, to address your question, I think there's still discussion needs to be about a program that AIA would actually endorse. But I did want to just mention that ILFI has a zero carbon certification program. So that has operational reductions, but for embodied carbon, they want to see to get zero carbon certification, right? Embodied carbon reduction of 10% for the primary materials, and then whole building embodied carbon to be less than 500 kilograms of CO2 emitted per meter squared. And then what they want to see then is an offset then of 100% of the construction and materials carbon. So they've kind of laid out that pathway to get to zero carbon. And as Baha has been saying, right, we're all still pretty early days with these tools and this analysis. And luckily, the market's just booming with technologies that Patti shared with us and all the tools that the presenters have been talking about today. So there's a lot more to do in this space and a lot more to come.
And on the topic of tools, I guess it might be good to talk a little bit, and I'd be curious to get Baha's perspective specifically, since I know you've used various LCA tools. Probably Patti and John have also used various tools. What do you recommend? What's been the easiest for you? I know each of these tools have different capabilities, different limitations. What do you recommend?
Yeah, so personally, I think I use a little bit of all the palette that's available, and right now I really think there's not just one single tool that could do it all. So that's a reason why we have so many different mini tools. But that's also promising because I think the industry, the designers, engineers, everyone is, we're understanding that we need more. Especially, I think there's a gap in early design, simple tools right now because we have tools that are more. The last few years, tools like Tally or so came out, and the focus was on BIM. So being able to get your whole building LCA from your BIM model, which is very promising. But then the challenge is that you need a fairly complete model to be able to run that study, that whole building LCA. Now I see, at least in the last year or so, many tools are coming out, kind of like early design, but also more focused tools like EC3, which, let's say, through Tally, you might start making decisions between going with a CLT or steel or concrete, but then you can get into EC3 later on and look at different concrete suppliers, or look at different carpet options based on a kind of product specific. I would say there's a palette right now. The minimal I would personally use is Tally and EC3. And I think the fact that the two are coming together is really promising. And again, Tally, Athena, or one-click LCA have similar functionality.
I think one of the challenges for us as a small firm is that we do not have specialists on staff who are very well versed in these tools. So when we do life cycle assessments, and we've only done them on 1 or 2 projects thus far, is to work with a consultant team that does have the expertise. And sometimes they're hired by us and sometimes they're hired by the client. But in that case, sort of building the team is more important than knowing what tool to use, if that makes sense, because you want to make sure that the team has, you know, the consultant you work with has the expertise in using the tools and knows the language and knows what the goals are. So in that situation, communication becomes very important, of just communicating the goals. But yeah, well, it's one of the big challenges is to implement these sorts of things within our office workflow, being a small office where we don't have people dedicated to this kind of stuff. So yeah, it's interesting where that's going to go.
Yeah, and I completely agree. You know, one of the reasons that we developed this LCA toolkit is because there's all sorts of tools, and you really need to pick the right tool for the right job. But John, one of the intents of the toolkit is to make it really easy so that you don't need to have an expert, but the tool is very accessible, because like Baha was saying in the very beginning, we need more data. And so whether it's used for making decisions on new projects or just figuring out how much carbon did we spend on our previous projects, I think the important thing is getting the information, and there, like, each tool has its own advantages and disadvantages.
Yeah, I think we'll start to use it more and more in our office. One of the challenges also is getting people to care about it. And it sounds kind of silly because it's something that we should all be caring about. But when it starts to get into when it starts to dive really deep into the numbers, some people aren't as interested in that as the more overarching sort of design philosophy behind the projects or other priorities. So that's also another challenge that we're working on, is really trying to get everyone invested and interested in this stuff. Yeah, so they kind of go hand in hand, because people won't, even if the programs are easy to use, they won't use them unless they're interested in what they can do. So
Absolutely, yeah. And actually we started doing, after we saw that correlation between embodied carbon and structural cost, we started doing LCA as part of our standard workflow on all our projects. But it wasn't really, I mean, it was something that everybody at Borough-Happold cares about. But when we saw that little nugget, that was sort of the motivation to, like, okay, yeah, we got to do this on all our projects.
One quick recommendation I have for for folks or firms that are just getting into doing LCAs, think about, and Patti just mentioned it too, think about motivations, but also incentives. I think Bleed is a good incentive right now, which I know it's kind of like a point-based incentive, but it's kind of like guaranteed, and you might find projects that are just interested. I've gotten many folks interested into doing an LCA just because of Lead. But also think about the larger picture. One challenge is that I see a lot of folks getting really deep into LCA and the numbers, but not necessarily. I think early on you could really focus on low-hanging fruits. It might be a little boring because you might hear concrete 10 million times, but if you could do optimizations that might take maybe not necessarily for LEED even, but just use some of the tools that are available, maybe a few hours of discussion to optimize your concrete and get a 10% reduction in your building. That's like building a building that's 10% smaller, but getting the same square footage. Focus on that for now. I know we need to do more, and we talk about the need that incremental steps are not the only thing that we could do, but think about the larger portfolio. If you could do 20 projects with 10% reduction, it might be better than one kind of boutique project that has a really large reduction. So start with the low-hanging fruits, and then you automatically get deeper into it over time.
That's great. And speaking of motivation and incentives, Brian has a great question for the group. So how do we move this conversation from design team to construction team, specifically concrete contractors? So what barriers do you see as needing to be addressed when we have those conversations with GCs and contractors?
I could talk a little bit about my experiences. One of the reasons we created the concrete LCA tool was basically that question, because in one of the examples that I actually showed, we did a lot of concrete optimization, and I think it was a Friday evening or something, the day before the concrete was being poured, and there were some issues and they changed the mix. So we had to run an LCA really fast, and back then we didn't have all these tools to be able to run it. So we came up with the idea of being able to kind of decouple a portion of high impact, like concrete or steel or so, from LCA expertise. So you don't really need any LCA expertise. You could just type your mix design in it, something that would be rapid, so you could use in meetings, and it would be decoupled from your Revit model too. So it's, in a way, it's really basic non-BIM kind of like a dumb spreadsheet, I would say. But then the benefit of it was that you expand the amount of audience that you have, or the amount of folks that would be interested to use it. And the way we started, usually we start by talking to the contractors. We start by providing just the NRMCA benchmarks as a baseline, and we say this is the average for, let's say, the California region or the Pacific Southwest region, and do not be worse than that. And then when that conversation starts, most folks usually just become a little interested in it. And because recently I think they hear carbon more and more, it's very unlikely that they would just ignore it.
Yeah, and we found doing a little bit of research ahead of time just to see what's available, so that what we're specifying, like Baha was just kind of alluding to, is something they can get a hold of. That's been important. Our bigger challenge, though, has been from the concrete suppliers, because most of the concrete suppliers locally are also cement producers. And so they don't have motivation to reduce the amount of cement that they're selling and including in their mix design. So that's a nut, I think, that hasn't been cracked yet. But I think as the industry in general puts more pressure on embodied carbon and reducing, I mean, if it's going to reduce the number of concrete buildings because they're so carbon intensive, maybe that's what will get the concrete industry here to be more open to incorporating some of these emerging technologies.
And just quickly looping back to John's comment about smaller practices having a difficult time finding the motivation within current staff to do this type of an analysis, to do an LCA, for example. I think that's actually one of the things that our working group at AIA California needs to start addressing, because I can see there's a lot of smaller practices that are going to have that challenge. And right now there does seem to be a developing gap between firms who have the resources or the expertise in-house to do this type of study versus firms, companies who don't have those types of clients. And if we're really going to make an impact as an industry as a whole collectively, then we kind of need everybody to be on board and somehow be incentivized to run these studies. There are a lot of buildings still to this day that are not really targeting LEED certification. But I do agree with Baha's point too, that if there is a building that's targeting LEED certification, that LCA point at this point is kind of a no-brainer. And it's a good little motivation. But yeah, just wanted to note that, John, that I am very interested in developing some sort of incentive, and we'd appreciate your input going forward.
Yeah, no problem. I think it's really just a matter of leadership, I think, especially at the small firm level. It's sort of a role that I fell into because it was something I was interested in. So really it's about developing the passion for it first, and then having people who will push it in their firms. A lot of times it won't come from the principal level. That in smaller firms, there's more influence on the day-to-day practice from the principal level than there is from, say, just project architects. But I think that if you have people who are interested in it and who are good at sharing that message, I think we'll do a much better job of getting that as part of just the day-to-day workflow.
There was a question I specifically had for Patti as you were talking through some of these structural alternatives, and it's something that we've come up against in our work, and I was just curious to get your take on it. You know, structural specifications have been developed over the years with sort of baked-in language, and it's all really geared towards safety first and foremost. A lot of things are exaggerated. Thresholds are sort of exaggerated just for a safety factor, for example. And specifically in concrete specifications, we are seeing a lot of structural engineers who are specifying, for example, a minimum water cement ratio. And that's been interesting because it's coming to a point where we want, of course, we want our specifications to allow for that safety, those safety factors. But what we're hearing directly from suppliers, for example, is that minimum water cement ratio disables them from coming up with a lower embodied carbon mix sometimes. So how do you balance that? Is that something you guys are addressing in your practice? Is that an industry-wide discussion?
Yeah, that's a really good question. So you're right. Of course, like safety has to come first. But what the approach that our group takes is more about performance specifications than prescriptive specifications, which was kind of the way of the past. And the other thing that we do regularly is go through all our specs kind of line by line. And we call it like greening the specs to make sure that whatever we're putting in there, it's really the best and latest information. And it's really achieving the sustainability goals that we're trying to get to and not inhibiting them like you're suggesting. So what my advice would be is if you are working with an engineer and you see something like that, or your suppliers coming back and saying like, hey, I can't meet this water cement ratio and achieve your sustainability goals, is have that conversation with the engineer. Because I would think like 9 times out of 10, the engineer can review that technical information and say, yep, this mix is safe, even though it has a different water cement ratio, and they'll go ahead and approve it. I do think that, you know, you all as architects have done such a great job of leading the way in terms of sustainable design. And I think that the engineering community is really trying to catch up and contribute and provide value. So I would think that most engineers would be more than happy to review those kind of technical changes.
Yeah, those are the types of engineers we want. And that kind of goes to Brian's earlier question about what are some of these challenges. I think that has definitely been one of the challenges. Our experience so far has been actually suppliers are pretty willing to work on this because they're all excited about claiming that their concrete is lower carbon than the other guys. So they're excited about it, but yeah, sometimes they run into issues with specifications, language that we've had there for years and just haven't looked at again. So that's definitely something for architects to discuss with their engineers in terms of the specs, 'cause that does have an impact.
Yeah, and it kind of goes back to one of Baha's first points is like starting this process early and having these conversations really early so that the whole team is working together to get to where we need to be.
And just a thought too, just for everyone on this call, and as you're talking to your local networks too, and especially kind of from the small firm perspective, if you have any thoughts or ideas on what AIA California COTE can do, what kind of resources we can provide on the website, if it's case studies, if it's a list of tools that are out there, please give that feedback to Hillary and Avide and myself, and we'll do our best to make sure that those resources are for you on the website.
Or develop some educational content around it. If it comes to that, we're definitely open to those types of suggestions to move the needle.
I think going back to our previous conversation, it's really important. I think we shouldn't underestimate the role of the client in getting some of this stuff pushed through, because engineers and architects and contractors can argue about things and try to solve problems, but a lot of times it comes from sort of the vision of the client to set the tone for the project. So we found that we get the best results when we are working with a client, not only who's technically savvy and has development experience, but also who has either a social mission or some sort of like community focused agenda, to where the sustainability goals apply not only to the building, but to the larger community. And so in that sense, there's like added motivation for the entire project team to do the best that they can to achieve the best results possible. So yeah, always talk to your client about it if you have concerns.
That's great. I guess Patti and Baha, I don't know if you have any kind of client-focused comments or perspectives to
I have a quick observation to share, not necessarily about clients, but just more about the concrete industry. I would say maybe a few years ago when we first started getting a little deeper into doing concrete LCA and then making that tool, I first got a few emails from concrete suppliers or cement producers too that were asking what EPDs were and so on. But in the last few years, I've seen at least some of these folks that I've talked to, I would say one of them, they've gotten from the point that they asked what EPDs were to the point that they produce product-specific EPDs for all of their mixes. And then another one was just given a presentation on carbon, and I learned so much from him just in a few short years. And they're also changing their products to use all type 1L cement. And if you look at the 2016 to 2019 NRMCA benchmarks, the benchmarks have gotten a lot better too. It's harder to beat, which is a good problem to have, but change definitely is happening.
Yeah, I don't have anything to add. I think those are really great comments.
Great. Well, I think we are coming up on our time here. Thank you to our speakers, Patti, Baha, and John. Thank you very much for joining us today, sharing your knowledge and expertise. Thank you to our attendees. If you guys have any further questions or suggestions, as Heidi mentioned, please do reach out to us. You can reach me or Heidi or Hillary. And if of anybody who would like to join this specific working group at a state level, please also reach out. And we hope you found this useful and informational. And I think we'll wrap it up. Any closing words, Heidi or Hillary?
Nope, just thank you for spending your lunch with us.
I agree. Thank you, everyone.
Thanks, everyone. Thanks for having me.
Yeah, thank you so much. This is really fun to talk about.
Yes, thank you.
Incredible content. So good. Thank you all.